Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing recursion topic. Today we'll do the third pattern of recursion, which is divide and conquer. It is another variation of non-linear recursion, but the only thing is in divide and conquer, overlapping subproblems are not there. Why? I'll show you with the example problem called binary search. So as we all know that in binary search algorithm, definitely the numbers will be given in the sorted order, correct? And we will be asked to find, let's say, target 5, correct? So to find our target value, there are two ways. First is linear search, where we iterate at every single point and check if that ith index value matches our target, correct? But that takes big O of n time complexity, because in that case, what if our target present at the last index? So definitely in worst case, we'll end up iterating to the entire length. But when the element is already sorted, we can apply binary search, and that is the second method. How? We start our left and right pointer and we calculate the midpoint, and from the mid index we decide कि our element or target value is present in our right side or present in the left side. So as we can see, target value is greater than mid element, so definitely this target value will be present to the right side. So in this way we have neglected or ignored the entire half length. Now we will move our left pointer, which was initially at 0, now will point to mid plus 1, correct? So our left pointer will be here, right pointer will be here, and again we'll calculate our mid. And now in this case, the mid value is exactly matching with the target value, so we return this, correct? So exactly this approach when we write instead of iterative, when we write using the recursion, and that's called divide and conquer recursion. And remember, I said there is no such overlapping problem. Why? Because in binary search, what we do, we divide this into two halves, correct? What? 1, 2, 3, one half, and second half 4, 5, 6. So basically we decided to search in this half, so we neglected this half, correct? Now we are going in this, means as per the mid element, let's say 4, 5 this side and 6 this side. So in this case, obviously our element lies here, so here the mid element we will return. So when you will see now the number of calls, there is no such overlapping, means even if we would have divided this, so we would have got 1, 2, 3 or 1, 2 and so on, right? 4, 5, 6 can never be the part of left subarray, correct? Because of this, all calls are unique, so hence there is no such overlapping problem happens, and hence no DP required. So personally I believe that this recursion is very easy and have very less chance of getting TLE. So now let's write the iterative code left side, and then we will change into recursive code towards the right side. So what we do, first we initialize our left pointer from 0 and right pointer from, let's say, length n minus 1, correct? Now we have to calculate mid, that we calculate by left plus right minus left divided by 2, correct? And also we will check ki what if let's say this is nums array, so if nums of mid value is exactly matching with target, then we can say this is the target we have to return. So we will simply return this mid if the mid index is required, otherwise we can return true also, okay? Else if, or if nums of mid, if this mid is less than target, then what do you think? Means suppose I have to find 5, okay? I have to find 5 and my mid is 3, so definitely it is less, mid is less than target. So definitely in that case our target lies in the right side, and now we have to search in the right half. So if we have to search in the right half, definitely our right pointer will not move, but our left pointer will move. But at what position? Mid or mid plus 1? Definitely mid plus 1. Why not mid? Because if our mid was answer, definitely this first if case would have passed, but this first if case said that this mid value is not matching with target. So when the exact mid value is not matching with target, then for sure we have to search in the next, means not including mid. So can I say here move your left pointer to mid plus 1? Yes. Else, but for that we have to mention in the else if, correct? So now in the else condition means nums of mid is greater, means let's suppose your target value was 1 and mid is greater than target. So definitely our target lies in the left half. So if we have to search in the left half, definitely left pointer will not move. But now right pointer we would like to move. But where? Mid or mid minus 1? Again the same rule, not mid but mid minus 1. So here what we will do, right is equal to mid minus 1. And I am sure you all are very much aware with this code. Correct? So here as we are moving our left and right pointer, left pointer ahead and right pointer behind, so definitely at one time they will cross each other. Correct? So let's imagine at a time when left is here and right is here. Let's say, is it valid? Yes, it is valid. Now let's say left is here and right is here. Is it valid? Yes, it is. Why? Because we are matching our target value only with the help of mid pointer, neither with left nor with right. So hence it is very important कि even if left and right pointer are pointing to the same number, same index, still we have to go for the check, so that mid will also point to the same index and then mid can able to match with the target. Correct? Yes. But what if right pointer is here and left pointer is here? I think this is not valid. Why? Because we have checked this entire and checked this entire. Correct? Until they were coming towards each other. Now they have crossed. So hence they are going to or approaching to those index for which we have already checked. So hence this is not valid. So what we will do, we will add this in a while case ki we will run only until they are less than equal. Otherwise we will stop. So after coming outside, if it was true, means if target was present in our nums array, definitely this if case would have returned the answer. Or else if we are coming outside without returning, for sure it was not there. So as per the question requires, if it asks to return false, then we can simply return false here. Or if it asks to return the index, then we can simply return -1, saying we have not found such target value. So what is the time complexity for this code? Definitely at every iteration we are dividing into half and going to the left half or right half. Correct? At every iteration. So at first you broken down to n by 2. Now second time you have broken down half of n by 2 means n by 4. Next time half of n by 4 means n by 8, n by 16 and so on. And this time complexity is nothing but logarithmic of n base 2. Why base 2? Again saying because we are dividing into 2 halves. Okay. So the time complexity is O big O of log n. Okay. Now if we write recursively, definitely the time complexity is not going to be optimized. But we are just trying to learn ki can we do or write the code using the recursion but with the similar approach. So let's see how can we change this iterative code into the recursive one. So as said, whatever condition has been mentioned in our while loop, that needs to be the base case. So till what we want to run until left is less than equal to right. So when we want to stop? Why? Because in recursion it keeps on running, but to stop we have to add a condition, right? So obviously if left is less than equal to right, it is valid. So if we want to stop, the base case should be if left is greater than right. Can I say that? Yes. So I can simply or blindly say ki if my left is greater than right, then we have to stop or return. Okay, done. Now what we are doing, this we are checking, we are calculating mid, we are checking and we are changing. So this will be the same for sure. What? Key, first we will calculate mid index. Mid index will be nothing but left plus right minus left divided by 2. Okay, and then we are checking ki what if nums of mid is equal to target. If it is so, then for sure I can say mid is a value, so we will simply return mid. Can I say? Else if, what we'll do? Ki what if nums of mid is less than target? If it is less than target, we have to go search in the right half. So if we have to go search in the right half, in the iterative code, we change the left pointer manually. But here in the recursive code, we have to call the same function and we have to change the value into parameters. Okay. So let's say this is a function with the array left pointer, right pointer and target. Correct. Now the thing what we were doing, ki if our nums of mid is less than target, so we were manually shifting this left to mid plus 1. Now in the recursive code, we don't do this manually. Instead we write the function, we call the function with same array, but left we will change to mid plus 1, here right and target as it is. Okay, so instead of doing manually, we have changed in the parameter, and this parameter will definitely take the updated value. And definitely you know that in the else condition what we have to do. Can I write here? Key function array left will be same, but right will become mid minus 1 and with the same target. Now the condition was key when we were coming outside the while loop, let's suppose we have to return the index. So outside the while loop, if we are here, so we can say ki we have not got any such index which is having the target value. So I was returning -1 here, correct? But don't you think in a recursive code, base case we have written na ki if at any case left is greater than right, means they have crossed each other. For sure they have not found the target value. So what do you think? What should we return? -1. Yes. So hence instead of simply returning, we have to return -1. Okay, and this code is also taking logarithmic of n time complexity, and this code is also taking the same time complexity. Okay, but the only difference is in the space complexity. Why? Because here you are not taking any extra space, but you know in the recursive code it internally uses a stack to save all the recursive calls there. That is basically taking extra space. But again, why we are learning this? To get habituated to how to write recursive code, number 1. Number 2, to understand there are nonlinear recursion where overlapping subproblems do not occur, and that's the case called divide and conquer. So I hope you get it. Now let me show you the code for this. So this is the code we have discussed. I am going to call the function, and this function we have to make. Okay, in this we are sending the array, left pointer, right pointer and target. Now the base case, if left is greater than right, definitely we have not found our answer, so we'll return -1, or else we'll calculate the mid value. We'll check if our target matches with mid, we will return mid then and there, or else two conditions which are return, like when our nums of mid value is less than target, for sure our answer is lying towards the right side. So for that we have to move our left to mid +1, or else we have to move our right to mid -1. So this code is also taking O of log n time complexity, but space is obviously log of n, correct? Why? Because that many number of calls we are doing, correct? So now let me submit this code for you, and definitely as the time complexity is less, so it will get submitted. Why it's fastest? Because if you can see here, the constraint says it's 10 power 4, means O of n is 10 power 4, and you are submitting in logarithmic of n. So 10 power 4 is, I guess, near around like 10,000 base 2, correct? So 1000 base 2 is 12 or 13, right? So 10 power 4 will be 4 more extra. Why? Because 1024 multiplied by 2, which is 2048 multiplied by 2, again 4000 and multiplied by 2, so 3 times. So it will be 16 or 17 around, but still it is very small, right? It's in constant. So this was your Java code, and here is your Python code with a similar approach. The recursive one I am showing you, and here is the C++ code if you are from C++ background. Again saying, this type of recursion you are not going to see a lot of time. Basically you are going to use in the divide and conquer type questions, where you can do in the iterative approach also, and if you want you can do in recursive also, but there will not be much difference in the time complexity in most of the cases. Okay, so if you understood this, we can definitely go in the sheet and mark the very first question. And now in the next video we'll do the next questions which are important. Okay, so I hope you understood what is divide and conquer and how can we do with recursion as well, and how it is very different from that overlapping subproblem nonlinear recursion. Okay, so that's it. With this, hope that you all have understood. I am expecting a like and a comment on this video saying you have understood or you have submitted along with me, like written the recursive code also for the binary search. If yes, and you are liking my way of teaching, definitely we'll meet in the next video. And if you have any doubt, you can even reach out to me on Instagram and LinkedIn. I'm very much active. I'll add the sheet link and the social media links there in the description below. That's it. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.